The law of constant composition states that in a given chemical compound, all samples are made up of the same elements combined in the same proportions. Let's use water as an example to make this clearer. One thing is true for all water molecules: they are made up of 2 hydrogen and 1 oxygen atoms. In other words, a compound that is made up of different elements or in different proportions cannot be water. In the water molecule, oxygen contributes 89% of the mass. But how do we calculate this? The percentage mass of oxygen within the water molecule is found if we add up the molecular mass of the oxygen atom, 16, with the molecular mass of the 2 hydrogen atoms, 1 each, giving us a total molecular mass of 18 for the water molecule. We then divide the molecular mass of the oxygen atom, 16, by the total molecular mass, 18. Finally, we multiply the quotient of 0.89 by 100, and there we go, the percentage mass of oxygen in water, 89%. You're already familiar with H2O, but oxygen and hydrogen do not have to combine to form water. They can combine in other ratios to form other compounds. Like water, hydrogen peroxide consists of 2 hydrogen atoms, but joined not by 1, but 2 oxygen atoms. Oxygen now contributes 94% of the mass. It is important not to get hydrogen peroxide mixed up with water. So what determines the ways in which elements combine? Well, it depends upon their positions in the periodic table, and on how many bonds they can form. Look at sodium. It has 1 electron in its outer shell, which it loses to form sodium+. It then forms ionic compounds to neutralize charge. So if it meets a chlorine minus, they form sodium chloride at a 1:1 ratio. Sodium has a molecular mass of 23 and chlorine a molecular mass of 35.5. You already know how to calculate percentage mass, so let's see if you can figure out the percentage mass of sodium in sodium chloride. Pause the video and resume when you have worked it out. Sodium makes 39% of the mass. We get that number by dividing 23 by the sum of 23 and 35.5, giving us 0.39, which we multiply by 100. Did you get that right? The law of constant composition is a useful tool for defining compounds, but it has its limits. Some compounds are non-stoichiometric, and their elemental composition varies between samples. These compounds have similar ratios of the same kinds of elements, but not exactly the same ratios. One such compound is iron selenide, FeSe. It forms close to Fe 0.9 Se. This non-stoichiometry gives rise to magnetic properties. Iron selenide is a low-temperature superconductor. Let's go over what we've discussed. The law of constant composition helps to define compounds and differentiate between them. All samples of one compound contain the same ratios of the same kinds of elements. Although it has limited applications in large compounds, it holds true for small molecular compounds like H2O. We have also learnt how to convert formulae into elemental content, mass percentages, a useful tool of analytical chemistry.